Do you like my little xylophone? Today, we're going to make and play a glass xylophone. We need just a few supplies. 3 identical glass bottles that have been emptied and cleaned, a measuring cup, a funnel, a marker, a spoon and/or chopstick, and a large container of water that is easy to pour. I also added food coloring to my water, but that is optional. I just wanted it to be easier to see. Finally, we need our science logs and something to write with. We are going to start with these 3 identical glass bottles that have been emptied and cleaned. Let's set them in a line and tap them gently with a metal spoon right in the middle of the bottle. We want to make sure they have a similar sound. If they don't have exactly the same pitch, that's okay, but for this experiment to work, they need to be really close. Let's hear these bottles. I would say that's spot on. If you have a chopstick, let's try with the chopstick as well and hear if there's any difference in the sound. It's the same note, but did you hear a difference in the timbre or the quality of the sound? Moving forward, feel free to use whichever of these you prefer. Now, let's grab our science logs and write down our first question. Will the sound change if we add water to a bottle and tap it? If so, will the pitch go higher or lower with added water? What do you think? If you expect the sound to change when water is added to the bottle, raise your hand. If you think the sound will stay the same, raise your hand. For those of you who think the sound will change, if you believe the pitch will get higher when water is added, raise your hand. If you think that the pitch will get lower when water is added, raise your hand. Go ahead and write down your hypothesis in your log. Now it's time for our experiment. We'll need to do a little bit of math. First, find out how many ounces are in your bottle. This bottle has 10 ounces, but yours might be different. Then, take that number and divide by 3. In this case, 10 divided by 3 gives me 3 1/3, and I'm going to round that to the nearest number, which is 3. Take a moment to find out how many ounces are in your bottle, divide by 3, and then round up or down to the nearest number. Feel free to ask an adult to help with this if need be. Next, take that number and double it. In my case, 3 plus 3 equals 6, so 6 is my next number. Grab your marker. It's time to label our bottles. I added a little bit of tape to mine just so that they're easier to see. On our first bottle, we'll write the letter A and the number 0. This is our control with a variable that stays the same to give a basis of comparison for our experiment. On the second bottle, we'll write the letter B and our first number, which for me was a 3. On the last bottle, we'll write the letter C and our second number, which for me was a 6. These last 2 bottles are part of our experimental group with varying amounts of water added. The letters that we wrote, A, B, and C, will help us differentiate among the bottles. The numbers represent how much water in ounces is in each bottle. On the first bottle, we will add no water, 0 ounces. Remember, this is our control. On the second bottle, we will add our first number. So for me, it is 3 ounces. I'm going to take my water and measure 3 ounces. And then add that to the first bottle. Using this funnel will help keep me from spilling. Now for my last bottle. It says here I will put in 6 ounces. So again, I'll measure 6 ounces. And then use my funnel to add it. And now we're ready to continue with our experiment. Let's test our experiment. Using your spoon or chopstick, tap gently on the middle of each bottle, noticing if there is any difference in the sound. If there is a difference, take note if the pitch is higher or lower when there is more water added. Write down your results using the descriptions highest, middle, and lowest to describe the pitch. What were your results? If you noticed a change in the sound when water was added to the bottles, raise your hand. If you noticed no difference in the sound when water was added to the bottles, raise your hand. Let's see what happens with my bottles. I also have a tuner app handy so we can find the exact pitch. Let's begin with the first bottle, bottle A, which has no water added. Can we hum this pitch? And according to the tuner app, it is a C. Moving on to the second bottle, which has 3 ounces of water. Can we hum this note? It definitely feels lower, and let's see what the tuner has to say. It is an A. Now for our final bottle, bottle C, which has 6 ounces of water. Can we hum this pitch? It's definitely lower still. Let's see what the tuner says. It's an F. These are my results. Based on these results, let's form a theory. As we add water to the bottles, what happens to the sound when we tap on them? When we tap the bottles, as we add water, the pitch goes lower. Just for fun, let's repeat this experiment, but this time blowing into the bottles like a flute. We'll record our results like before, noting which bottle has the highest pitch, which has the lowest, and which is in the middle. Were you surprised by the results? Let's see what happens with my bottles. Starting again with our control, bottle A, which has no water. Can we hum this note? And according to the tuner, it's a G sharp. Next, bottle B, which has 3 ounces of water. Can we hum this note? And according to the tuner, it's a C sharp, which is higher. Now for the last bottle, bottle C, which has 6 ounces of water. Can we hum this note? And according to the app, it's a G sharp, up the octave from this bottle, so it's the highest of all of them. I went ahead and recorded my results in a table, which looks like this. Wow! Depending on whether I'm tapping on the bottle or blowing into it, adding water produces completely different results. If I'm tapping on the bottle, adding water produces a lower pitch. But if I'm blowing into it, adding water produces a higher pitch. Why would this be? Let's think back on what we've learned about how sound travels through different forms of matter. As we know, sound can travel through a solid, liquid, or a gas. When I'm tapping on the bottle, we're hearing the sound of the glass vibrating. As I add water to the glass, it slows the rate of vibration down, yielding a slower frequency or a lower pitch. Then, when I blow into the bottle, you're hearing the sound of the air vibrating. When I add water to the bottle, it leaves less room for air, yielding a shorter air column or a higher pitch. This is why, depending on how you play this instrument, it will change the sound. When we're tapping on the bottle, we're hearing the sound of the glass. And when we're blowing into the bottle, we're hearing the sound of the air. Here's a DIY project for you to try on your own. Create a short melody using your bottles, either as a glass xylophone, a flute, or combining the two. Notice all the different notes you can produce on your instrument. Later, you can share your composition with your class. Thank you so much for joining me today in making and experimenting with the glass xylophone. I'm Miss Liz from the Cincinnati Symphony Orchestra Sound Discoveries program. See you soon!